Assalamu alaikum. I'm Zafar and I'm going to describe my project, which I have made with my group member Laraib Imtiaz. My project is obstacle avoiding robot. Before going into the details, let me introduce you with the components I have used. And these components includes Arduino Uno, a motor driver that is L2938N motor driver for driving the motors, an ultrasonic sensor that is HCSR04. You can also use HCSR05 ultrasonic sensor. The only difference between SR04 and 05 sensor is that 05 includes one more pin, that is output pin. So if you are going to use SR05 ultrasonic sensor, then don't use the output pin. And a chassis in which you can see that motors are already connected with it. And we have used male to male jumper wires and also male to female jumper wires. Here is a circuit simulation of the project. In this you can see that I have used 3 ultrasonic sensors with Arduino Uno and a motor driver with 2 motors. In sonar 1 you can see that trigger pin is connected with the pin number 11 and the echo pin is connected with pin number 10 of Arduino Uno, and the other pin is grounded and the 5-volt pin has provided 5 volt externally. Similarly, in sonar 2, echo pin is connected with A5 pin of Arduino. Trigger pin is connected with 12 pin of Arduino Uno. One pin is grounded and the other pin has provided 5 volt. Sonar 3, trigger pin is connected with pin number 13 of Arduino. Echo pin is connected with A4 of Arduino, 5 volt and grounded pin. Now the motor driver, in which input 1 is connected with 9th pin of Arduino. Input 2, input 3 and input 4 are respectively connected with pin number 8, 4 and 3 of Arduino. Enable A and enable B are connected with pin number 5 and 6. Sense A and Sense B pins are grounded. And output 1 and output 2 is connected with motor 1. And output 3 and output 4 is connected with motor 2. Twelve volts are provided to motor driver. Additional battery for the smooth driving of motors is provided to the motors. And here we have the circuit. So now we will go in a real circuit. So here is the actual circuit of my obstacle avoiding robot. In this you can see that I have used 3 ultrasonic sensors. One is right here, this is the second one, and a third one. I have used HCSR05 ultrasonic sensor and SR04 ultrasonic sensor. As I have already told you, you can use both of them. It doesn't create any difference. This is the Arduino board. Here is the motor driver L2938. There are 3 batteries I have used. You can use a single 12-volt battery as well, but that battery is little expensive, so I have used these 3 batteries. You can use only 2 batteries, but to increase the performance, I have used the 3 batteries. Connections are according to the Proteus simulation, which I have already told you. So I'll repeat only the connections for the one ultrasonic sensor. That is the right one. Here one is VCC connection. Right here. And its wire is green. This wire is connected right here. I have used a 5 volt from Arduino. You can get 5 volt from this pin. That is visible, I think. This pin directly gives you exactly the 5 volt, so I have used this for all the ultrasonic sensors. I have applied all these sensors 5 volt from this point, so I have used a common connection for this all. This is the echo wire of the sensor, and this is connected to A5 pin of Arduino. Yellow wire is for the trigger pin of ultrasonic sensor, and it is connected to 12th pin of Arduino. And similarly, all the connections are same as I have already told you in the circuit simulation. And this is the ground wire, and I have used a common connection for grounds as well. Here are all the grounds of sensors, and I have given them ground from the Arduino board. This is the motor driver. Motor driver has applied with 12. It's a 9 volt battery that is directly connected to it. So this battery is giving 9 volt to motor driver. This also required 5 volt, and I have given this 5 volts from the same connection which I have used for the ultrasonic sensors. So this is it from the circuit point of view. Here is the coding of the circuit. And start, the input and output pins are declared and initialized. The actual programming starts from the loop. In this, F-dis is actually the distance from front sensor, R-dis and L-dis are the distance from right and left sensors. Then we have applied few conditions that if distance from front sensor and from right sensor is less than 15, then go to left direction. Similarly, if distance from front sensor and from left sensor is less than 15, then go to right direction. If obstacle is only at front, so then go to right direction. and if obstacle is from front, left and right direction, then go in reverse direction. Otherwise, keep on moving in forward direction. For forward direction, the sequence is high, low, for input 1, input 2, input 3 and input 4 pins. And analog right, enable A is declared 255 and enable B is declared 255, which is actually determining the speed of the motors. And I have declared the maximum speed of the motors. Similarly, for right direction, sequence is high, low and low, high. For left direction, sequence is low, high and high, low. And for the reverse direction, the sequence is low, high, low and high. Here is how the front sensor is finding distance. Similarly, right sensor is finding distance and the left sensor is finding distance. From there, they find the distance and send it to these locations, and by using these distances, we applied these conditions. So this is all from our side. Hope so this will help you to make this report. Thank you so much.